file permissions. Linux file permissions. Note down, every file and or directory, every file or directory in Linux has access permissions. Every file or directory in Linux has access permissions. Access permissions. There are three types of permissions. One is read access. Second one, write access. And third one, execute access. Every file or a directory in Linux has its access permissions. So we have three types of access permissions, like read access, write access, and execute access. Note down, like permissions. Note, next point, like permissions, there are three types of users. Three types of users. Full stop. Permissions are defined for. Full stop. Permissions are defined for three types of users. So one is the owner of the file. Owner of the file. Next, the group that the owner belongs to. The group that the owner belongs to. That means user primary group. User primary group. Other users. Other users. Right. So next, note down, Linux file permissions are 9 bits of information. Linux file permissions are 9 bits of information. Each of them may have just one or two values. Just one or two values, allowed or denied. Allowed or denied. Okay. File permissions notation. File permissions notation. First one, textual representation. Textual or symbolic. Textual or symbolic representation. Textual or symbolic representation. Right. Read access which represents or textual representation, write access W, execute access X. Okay, so read access represents in a textual representation, or write access textual representation W, execute access textual representation X. Okay, so these read, write, execute access we can set on users, on group, on others users. Okay, so next, note down numeric notation. Numeric representation. Numeric representation. Numeric representation. See, read access 4. Write access 2. Execute access 1. Right. In textual representation, read access or write access W, execute access X. In numerical representation, that means octal, read access 4, write access 2, execute access 1. Execute access 1. Fine. See, 9-bit notation, right? So 0 0 0 0 0 0. User, group, others. So we can set read, write, execute access. We can set read, write, execute access. We can set read, write, execute access for users and groups. Okay. We have a user account, owner of the file. Okay. In textual representation, we can represent like U, owner of the file, user, group G, other users O, above all A. So note down this. Okay, U, it represents owner of the file. Owner of the file. In G, group, that the user belongs to. O, other users. A, above all means user, group, others. It represents. A represents user, group, others. Fine. User, group, others. Read, write, execute. What it means? Full access, right? When you give permissions are like read, write, execute access, full access. Read, write, execute. Full access for user, full access for group, full access for others. So when you said permissions are like on file or a directory in the file system, everyone can access, everyone can read, everyone can write, everyone can rename, everyone can delete. When you give full access for every user accounts, so not only owner of the file, Here we given, right, permissions to group and others also full permissions. The same thing in numerical representation. 7. 4 plus R represents 4, right? 4, 2, 1. Add the value 4 plus 2 plus 1. What is the total value? 7. Yes, which is equals to 7. So same thing here, 7, and here also 7. 777 in the sense full access. 777 full access. Based on requirement, we can set permissions for user, group, others. For that, we have a command like chmod. We will see that. Okay. See, in octal digit, if it is 0, what it means? If you specified 0, octal digit. 0 in the sense, no access. Is it correct or not? No access. 1, what it means? Execute access. It represents. 2, write. There is no read and execute access. 3, write and execute. There is no read access. 4, read only. Read only. Read only. No write and execute access. 5, read and execute. No write access. 6, read and write. No execute permissions. 7, read, write, execute. Same thing, right? Use the values as per requirement. We can set permissions. We can set permissions. See, we can change file permissions using symbolic notation, or that means textual representation, or absolute notation like values, digits we can use. Okay, if you want to set read write access, then what is the value we have to use? Read write 6 for user. So if you want to set a read only access for group, 4, or we can use in symbol textual representation group G. So we have operators like plus and minus, G plus R, like. Okay, we'll see that. Okay, right? By default, when you install operating system on file system, there is a default mask value. Based on mask value, permissions will be applied for files and directories. Permission directory. So we have a U mask, user mask, user mask. Right. Based on umask value, permissions will be applied for files and directories in the file system. Okay. So by default, so for root user and users, there is a different mask value. Okay. When you log in as root, if you created files and directories, files and directories will get different permissions for user, group, others. When you log in as normal user, if you created a file or a directory, files will get different permissions. So there is a different mask value for root and different mask value for users. Right. First we'll see the default permissions. Default permissions for root on files and directories based on that mask value. File permission 644. What it means? 644 read write for read only and read only. Right? See 6. What is 6? Read write access for user, read only access for group, read only access for others. If you specified values like this, That means default file permissions. When you create a file like file1.txt something PDF, any file, okay, permissions are like this. Directory permissions, default directory permissions for root 755. The same thing in textual representation. Read, write, execute for user, read and execute for group, read and execute for others. Octal representation, textual representation, right? Default permissions for users, that means normal users. File permissions 664. The same thing in textual representation. Read, write, no execute access. Read, write, no execute access. Read only, no write and execute access. Execute, read, write, execute, read and execute. Read, write, execute, read, write, execute, read and execute. So these are all the default permissions for root user and normal user accounts. Okay. Note down default mask value, umask value. Default umask value for root. Zero two two. Users 002. Default umask value for users. See, based on this masked value, permissions will be applied on files and directories. Based on this masked value, permissions will be applied. So what is masked value? So here masking for permissions. That means based on mask value, you will get a default value permissions. So how you will get that? Default permissions equals to full access minus umask value. You will get a default permissions. When you set a mask value, okay, so whatever the values you specified in the mask, okay, those values will be minused from full access. Minused from full access. Full access. See, what is full access in the sense? Yeah, read, write, execute. So read, write, execute for user, read, write, execute for group, read, write, execute for others. What is the default mask value here for root? 0 is mask value for root, user. Yes. 2 is mask value for group. 2 is mask value for others. What is 2 in octal representation? Write access. Right? That means remove write access for group, remove write access for others. You are not removing any access permissions for user, giving full access for user. Now minus the value. When you remove write access for others, 7 minus 2, 5. The same thing, read and execute, right? Once you remove write access, others will get read and execute permissions. The same thing, 5. When you remove 7 minus 2, 0. Sorry, 7. 7 minus 0, 7. 755. See, default permissions are not there. No? Root, default permissions for directory. 755. 755. It means full access for user, read, write, execute, read, execute for group, read, execute for others. Okay. So this is default directory file permissions. Default directory file permissions. Once you remove mask value from full access, you'll get a default directory file permission. Default directory file permissions. Okay. Right. So directory permissions we got, right? Now what about regular file permissions? Now remove execute permissions from default directory permissions. Default directory permissions, we have to remove execute permissions from that. See, remove execute permissions. The same thing represent like read, write, execute, and read and execute, read and execute. 755, right? Means 7 5 5. Same thing. Remove execute permissions. Minus removing execute. What is the value you'll get? That means read, write 6. Okay. Once you remove execute permissions here, read only. That means 4. Again, read only. 6 4 4. The default permissions for files, right? 644 default permissions for root. Right? So based on the mask value, file permissions are like this. The same thing for normal user also. The mask value for normal user 002. Once you remove mask value from full access, you'll get a default directory permissions like 775 and file permission 664 based on this mask value. So now let me check the file permissions. ls-l. When you run ls-l command, file permissions, it shows on the second field for every file. Okay, see what is second field? File permissions, right? So read, write access for user, read only access for group, read only access for others. What is hyphen means? No execute access, no write and execute access, no write and execute access, like it shows. Okay. Yes. Okay. When you create a directory will get permissions are like this: read, write, execute 7, read, execute 5, read, execute 5. Okay. So let me check. Create a file mkdir on directory test2dir. Take the permissions. What it shows? Permissions: read, write, execute, read, execute, read, execute. See, not root login. File, we can set files, permissions on files. Like there are 3 types of users: owner of the file, group owner of the file, and others. So for user, here given full access. Who is owner of the file? Root. Root is having full access, right? For root group, only here provided read and execute. There is no write access. They can't write. They can read. The group members, root group members can read files under test directory, but they can't write something into test directory. Like others also. The users not belongs to group and not a owner of the file. Those users are called other users. Okay. So those users are also read. They can't write something into the directory. Okay. These are all default permissions. Create a file now. Test file. ls-l test file. See the permissions. Read, write. That means 6. Read. There is no execute access for user. Read only permissions for group. No write access. No execute access. Read only permissions for others. No write access. No execute access. Execute access. 644. You got the same values, right? Now run. If you want to see the mask value, run umask command. Using umask command, we can set new mask value, and we can view existing mask value. So note down that point. Using umask command, we can view existing mask value, and we can set new mask value for user. We can view existing mask value, and we can set new mask value for user. Fine. See, here executed umask. It shows 0022. See, first 0 on the bit. First bit, it represents special permissions. So we'll see what is special permissions later. The remaining 3 bits are actual permissions. That means traditional file permissions for user, group, others. Read it. See, based on this mask value, files will get permissions on user, group, others. Right. If you want to modify mask value, you can umask 002. Now run mask command. Modify. Now create directories. See, permissions modified, right? Based on the new mask value, file got permissions like this, directory got permissions like this. Is it correct or not? See, read write access for user, read write access for user, group, read only access for others. That means 664. 664. And directory permissions 775. Read write execute access for user, read write execute access for group, read and execute access for others. 775. See, full access means this one, right? What is the mask value? 002. Once you remove, yes, 755. Sorry, 775. Okay, and once you remove execute permissions from this, so you'll get a directory permissions, sorry, file permissions like 664. 664. The same thing we got, right? After modifying mask value. Okay, so after setting the new mask value, once you created a file, files will get new permissions. See, the same thing here applied. A number of files we can create directories. The files will get the same permissions based on new mask value. What about the existing files? For existing files, it won't take effect. Still remain it's the same permissions. Okay. So if you want to modify existing file permissions, we have a command called chmod. We'll see how to change permissions using chmod. Right. Switch to another console. Or we can switch from here. su-switch user. We can switch from one user account to another user account. Su space hyphen username. See, successfully switched from root user to test user environment. Now run mask value. Currently we are at normal user environment. When you run mask value, what is the default mask value here? 002. That is what we discussed, right? 002. Based on this mask value, permissions will be applied on files and directories. Create a file. File 1. See, permissions on file. Read write access for user, read write access for group, read only access for others. Directories, read write execute access for user, or read write execute access for group, read and execute access for others. Based on the mask value, permissions are like this. We can modify mask value. Set the new mask value using umask 022. 022. Now run umask. What it shows? New mask value, right? Now create files and directories mkdir test touch. One new file created, one test directory created, ls-l. Let me check the permissions now. So what is the permissions on new file? Read write access for user. That means there is no execute access. So in Octa representation 6. Read only 4. Read only 4. 644. Based on mask value 022, file permissions are like 644. And directories. What about directory? Test directory we created. Okay. So after setting the new mask value, we created test directory. On test directory, permissions are like this. Read write execute for user, read execute for group, read execute for others. 755. 755. Like we can modify. As per requirement, we can set the default file permissions. Using mask value, we can set default permissions on file system. Default permissions on file system. So once you set the mask value, whenever you created a number of files and directories, those files and directories will get the same permissions. Same permissions for user, group, others. As per requirement, we can customize permissions for user, group, others. But by default, the same permissions will be applied. Yeah. Yeah, we can switch from one user to another user. When you switch from root user to normal user accounts, no need to provide any password. It won't prompt for password. When you switch from a test user account to example user one user account, so then it will prompt for user one user account password. No, not logged in user. You are switching from test to user one, right? User one password you have to enter. I didn't get you. See here, switched from root to test user. When you switch from root user account to any other user account in Linux box, no need to enter password. It won't prompt for password. Directly user account will be switched. So when you're trying to switch from normal user to any other user accounts, it prompts for password. Which user password? New user. Whatever the username you specify to switch, that user password it will ask. Example, we have a test user. Currently we are a testing login. Test 2, if you want to switch user 1, it will prompt for user 1 password. Okay, we have to enter user 1 password, then only we can able to log in as, right, su hyphen. Right, based on mask value, permissions will be applied. Okay, user mask value. If umask value 0, then tell me the default permissions. If mask value 0, default permissions 7, full access, right? 7 minus 0, mask value in the sense minus the access permissions from full access. We have a full access, read, write, execute. The same thing in octal representation, 7. 7 minus 0, 7. That means full access. Mask value 1. 6, right? What it means? Read and write. Read, write access. Mask value 2. Once you remove write access from full access, you'll get read and execute. Read and execute access. 3. Read only. Read only access. Write and execute. 5. What is 5 means? Read and execute. So remove read and execute permissions, you'll get write only permissions. Write only access. 6. Mask value 6 means removing read and write permissions. That means execute permissions. Execute access only. Mask value 7. No access. No access. Okay. See, mask values are like this. As per requirement, use mask value for user, group, others. Now we can use mask value for user, group, others, right? See, example, for user, mask value 0, group 1, mask value, others 2. Then tell me the default permissions. 777 user mask value, group mask value. Tell me 5, right? So don't remove the values. Execute permissions. We have to assume like this. Okay. Read, write, execute. From read, write, execute. The value 2 means write. Remove write access from read, write, execute access. Once you remove write access, others will get only read and execute permissions. The same thing we represented in octal. 5. Read and execute. Once you remove execute permissions, read and write. Then full access 765. The same permissions will be applied on directories. For file permissions, we have to remove execute permissions. So now tell me, after removing execute permission, 7 execute. Read, write, execute here. Read and write, and read and execute. Now remove execute permissions from. Once you remove execute permission, read, write, and read, write, and read only. 664. Okay. So when you minus the value 1, what will happen? You get the different value, but for permissions will be applied like 6. Okay. Don't get confused. We have to remove the values, not value. Access modes, read, write, access. Okay, so 6, 6, 4. Like you can use mask value for user, group, others from this as per requirement. Okay, so we can set different mask values for different user accounts. Different mask values for different user accounts. Based on mask value, permissions will be applied on files and directories. Got it? Fine. We'll see. Here, mask value modified using umask command. Once you set down new mask value, the mask value is available for only this particular session. Once you relog in, okay, so again it takes effect to the old mask value. Okay, to make it permanent, we have to add this mask value into user environmental files. We have a .bash underscore or sorry .bash rc .bash underscore profile files. So we have to enter into bash rc file or bash underscore profile file. Umask space the value, or these mask values are applied based on the values at global profile file. So we have a global profile file /etc/profile. So this file contains masked values. See here, first one, what it shows by default, we want umask to get set. This sets it for login shell. If UID greater than 199, what is UID? User ID. If UID is greater than 199 and specified something, mask value for those UIDs 002. When you create a new user account, by default user account will get a UID from the range 1000 onwards, right? See, greater than 199, UIDs will get the mask value 002. The remaining UIDs will get the mask value 022. So if you want to set the default mask value for all user accounts greater than 199, so just modify this value. Set mask value for user, group, others. Here, what is the mask value for user? 0. Mask value 0 in the sense full access. 0 means full access. Mask value 0. Okay. Mask value 0 for group. That means full access. And others 2. Others means no write access. Removing write access for others. Only other users will get read and execute based on this mask. Here we can modify the values. Got it? Fine. Global profile file /etc/profile. So we have a bash RC also. So this file, it contains some shell environmental configurations, functions, and the values. When you log in as user, see here also it shows, right? The same thing. Same thing it shows here, right? Same values here also it shows. We can set some environment here. Once you set the new environment, okay, when you log in as root or any user account, login shell process will read this config file. So whatever the environment we defined, the same environment will be loaded. Same environment will be loaded. Okay, first it reads global profile file /etc/profile /etc/bash rc. So then it reads user local profile files, dot bash rc dot bash underscore profile. Right? So we can set a different shell environment for different users. If you want to set the same environment for all users, we have to update the settings into global profile files. Global profile files. Fine. So this is read, write, execute, access. How to set permissions. Okay. How user will get permissions, group will get permissions, others will get permissions. Okay. So based on umask value only, users, group, others will get permissions on files and directories. Okay. So based on permissions, they can read, write, execute. They can read or write only. Okay. Fine. Now we'll see how to modify existing file permissions. Once you created a file, automatically files will get permissions. As per requirement, if you want to change permissions on files or directories, so for that we have a command chmod, change mode, change access modes, change access modes, chmod, options, permissions, then files or directories. Right? chmod, options, permissions, files or directories. So here we have to specify permissions for users, group, others, and these permissions will be applied whatever the file names and directory names you specified. Right? Here we have two methods to set different permissions for different users. One is textual representation, second one is octal representation. Okay, first we will see textual representation. So how to set permissions, so how to modify existing user permissions, group, others. Right? chmod. For example, we have a file called file1. File is having permissions are like this 644. Okay, now I want, so here 644 means read write access for user, read only access for group, read only access for others. Now I want to allow group users also write. I want to allow group users also to write something into the file1. Okay, so for that we have to set write access on group. Group already having read only permissions. Now we have to allow group users to write something. So in textual representation, group G, right? G plus, we have a plus and minus operators to add and remove permissions. To add permission, use plus operator. Okay, if you want to remove permission, use minus operator. Plus, right, G plus W. Okay, adding write access to group, file name, file1. Once you modified, when you run ls-l file name, file1, it shows permissions are like 664. Right? Adding additional permissions. right? The same thing in octal representation, how to set ch mode. Here we have to specify three values: user, group, others. See, already user is having 6, cannot modified, okay, using same values. Now group is having 6. Now we want to allow group users to write something. 6 plus 2, sorry, 4 plus 2. What will happen? 6. Then 4. File 1. We have to specify. So if you specify only 4 instead of this, what will happen? The value 4 means read access. Read only permissions will be applied on others, and the permissions will be removed on user and group. That means user will get no access, group will get no access. If you set the permission like, okay, we have to specify user permissions, group permissions, as well as other permissions. Even though you want to add or minus permissions on user or group others. In octal representation, we have to specify user, group, other values in the syntax. Right. If you want to add execute access for user, for that chmod u plus x, then file 1. The same thing, the file is already having 664 permissions. Now 6 plus 1, that means read, write, execute 7, 6, 4. They are not modifying any permissions for group and others. 7, 6, 4, file 1. This is an octal representation and this is an textual representation. Yeah, you giving execute permissions. So when it require execute permissions, if that file is a script file, so required execute permissions. Okay, so basically not required execute permissions for any regular file. So only execute permissions is required for binary files. That's why, okay, when you create a file will get without execute permissions. File will get permissions without execute. Okay, so when it requires, we can set execute permissions like. If you want to set execute permissions for all user, group, others, how to do that? A plus X. What it means? A. Yes, above all in the sense A represents user, group, others. A plus X. Setting execute permissions for user, group, others. File name or directory name. So if you want to remove execute permissions for all user, group, other, A minus X, file or dir directory. Right. If you want to remove write access for group, G minus W, file or directory. chmod so if you want to add execute permissions for user, write access for group, okay, so no access for others, see, u plus x, adding additional permissions, comma, then G minus W, remove execute permissions, O minus read, write, execute, removing all permissions. That means no access for others, file or dir. Separated by commas, we can set. different permissions for user, group, others. Right? The same thing, a plus x, we can represent like, we can execute like this also. UGO plus x, user, group, others. A represents user, group, others, right? The same thing we can use like this, the syntax. UGO, instead of A also UGO. If you want to add permissions, to all, plus, minus, minus operator, the access modes. File or directory. Right? Right? Fine. So we can use equals to also here if you want to set chmod u equals to rwx g equals to read write or read execute. Okay. Others equals to read only, file name or directory name. You can say. Right? So this is how to set permissions for files. See, now practically we'll see. Okay. There we have a number of files. Okay. Let me change directly to somewhere. Okay. Fine. So here we have a Apple file. The file is having permissions for like 644. Now I want to add read and write access for group. Okay. So who is owner for this? Root. Who is group owner? Root. Right? chmod g plus w, file name Apple, ls-l Apple. Modified? Permissions modified or not? Yes. Modified, right? Read write, read write, read write. Before it's read only permissions for group. Now read write permissions for group. Group users can write something into Apple. Like, pardon? Yeah, we can. If you remove write others separated by commas, we can set. So here remove write access for group, added write access for others. Let me check. Modified or not? Yes. Read write for user, read only for group, read and write for others. That instead of file name, we can specify directory name also. Like n number of files at a time we can change. So if you want to set the permissions recursively for directory as well as subdirectories, inside subdirectories files. That means all files under a directory. We have a capital R option. chmod hyphen capital R permissions, then file name or directory. Capital R permissions, file name or directory name. To change permissions recursively on directory and directory inside files. This one. Note down the syntax. Change permissions recursively on directories and directory inside files. So note down on small note point. Minimum and maximum umask value for a directory. Minimum and maximum umask value for a directory is minimum 00 and maximum 777. Next point. Minimum and maximum umask value for a file. Minimum 00 and maximum 666. Right? Got it? Next, note down one more point. By default, files will get without execute permissions. Will get without execute permissions. Okay. Execute permissions not required for regular files. Because regular files. Execute permissions not required for regular files because parent directory is already having execute permissions. Parent directory is having already execute permissions. Okay, so full stop. Execute permissions only required for scripts or binaries. Execute permissions only required for script or binary files. Fine. Got it? Now we'll see how to change ownership and group ownership of a file. Okay. So for that we have a chown command to change ownership, chgrp command to change group ownership. So up to here we modified permissions on user, group, others using chmod, right? Using umask, setting default permissions for files and directories. Now we'll see how to modify existing ownership. So how to modify existing group with new group. chown to change ownership of a file or directory. Username, then file or dir name. Right? chgrp to change group ownership of a file or directory. File or directory. Yeah, group ownership. Right. So under OPT we have a file Apple, right? See, Apple is having permissions read write, read only, and read write for others. So modify permissions to 644 Apple. Sorry. Read write, read only for group, read only for others. Okay. So try to access this file, login as test user. Write something into that. What will happen? We'll see. su-switch to test. Switch to test and access the directory /opt. Change directory to opt, then read file or try to modify. Or we can directly use absolute path, right? cat /opt apple absolute path. It contains some text. Okay. So test user is successfully accessed file, right? Now try to modify file. That means append data into that. What it says? Permissions denied because there is no write access for others. Test user belongs to root group? No. Test user is not belongs to root group. See, Apple file owner is root. The Apple file belongs to root group. Only the members in that root group also can read. There is no write access. For others also, there is no write access. Only user can read write into this Apple. Right? So if you want to allow other users to write something, yes, we can set chmod then o plus w opt apple. What it says? Operation not permitted. Who will modify? Only owner of the file. Owner of the file, that means administrator, or administrator can modify file permissions. Who is owner for Apple file? Root. Who is group owner? Root. Test user not a owner of the file, not a member in that root group. Okay. Now switch to root user. When you switch from normal user to root, then it will prompt for root user password. Enter root user password. We can switch from that. Now change permissions. The chmod o plus w /opt apple. Okay. Modified? Yes. Exit from that session. Now currently we are a test user environment. Now try to modify, try to append data. Allowed or not? Allowed. So not only test user, any user can write something into this. Allowed other users. Other means all users except group, except group members. If you added users into group, those users can't modify, only they can read. What is the permissions on group? Read only. Whatever the users belongs to root group, those users can read. They can't write something into the file, only other users. Other means the users not belongs to group, not a owner of the file. But any user can modify. Okay, so if you want to allow your group users only to write, okay, no access for others, then switch to root, then modify chmod g plus w o minus w, then apple. Now after modifying permissions, what will happen? User and group got read write access, read only access for others. That means other users only they can read, they can't write. Okay, now group members can write something into that. Okay, see why we have to set permissions on group. If you want to allow a specific users to write something into the file, not all users. So whatever the user accounts available in your Linux box, you don't want to allow. If you want to allow a specific users to write something into, then add users into file group, then set permissions on group, write access. Then whatever the users you added into root group, then those users will write something into that. Right, see now, exit from this, try to modify again. What it says? Permissions denied. Now add test user into root group. Okay, how to add? How to add a user into one group? User add. Exist. How to add a user into one group? Group add. So we can create groups using group add. How to add a user? We have a user mod command, right? Using user mod command, we can add user into supplementary groups. Using gpassword, we can add a user into multiple groups. Okay, user add command for new users. At the time of creation, if you want to add a new user into supplementary groups, user add. For existing users, user mod command we have to use. The test is already exist, right? Okay, now add test user into root group. User mod hyphen capital G. So along with capital G, use A option. So append hyphen A, append. That means if that user belongs to other groups also, if not specified A option, it overwrites with new supplementary group. So whatever the existing supplementary groups are there, those supplementary groups will be overwritten with new supplementary groups. Okay, existing supplementary groups. Along with that, if you want to add a user into another supplementary groups, then use hyphen A with capital G. So now specify group name, root. Username, test. Added or not? Yes. If you want to check groups, test. Test belongs to root group. Now, root group or not? Yes. Sieve hyphen test. Switch to test. Now try to access OPT. Allowed or not? Because root group is having read write access. Once you added users into that group, users will get the same permissions. Okay. Successfully updated. Modified or not? Right? Like we can add users into groups. So we can set permissions on group as per requirement. Right? See, there are some requirements like instead of using existing group, okay, based on the project name, we have to create a group and user accounts. So then we have to add existing files into new group. Existing files into new group. Okay, then add users into the same group. If file belongs to same group, users belongs to same group. Whatever the permissions on the group, users will get the access on files. Right? Here we'll see how to change group ownership for Apple file. So for that, create a group add G1. Okay, so G1 group already we have G1. Next, okay, CHGRP group name G1 Apple. Here modified group ownership. That means Apple file removed from root group, now added into G1 group. ls-l. See, modified or not? Group ownership. Now Apple file belongs to G1. Now try to access file, login as test. What will happen? We'll see. Yes, test user successfully accessed. Try to modify, append something into that. It shows permissions denied. We added user into root group, but file removed from root group. Okay, who is group owner for Apple file now? G1. Again, we have to add user test into G1 group, then set permissions on G1 group. Already G1 group is having read write. Read it or not? Yes. Add test user into that group now. See, user mod -a lg group name, then username. Allowed or not? Like we can change ownership also. If you want to change ownership, we can change. So how to change ownership? CHOWN, CHOWN, change ownership. Change ownership. That means Apple file is having owner root. If you want to modify root to test, we can. User name, then file name. OP Apple. ls-l opt Apple. See, ownership modified or not? Yes. Who is owner for this file now? Apple. Test user. User is having read write. Right? Like we can modify ownership and group ownership using CHOWN, CHGRP commands. Using chmod command, we can modify access modes. Right? Using CHOWN command, we can change ownership as well as group ownership at a time. So for that, we have to execute command like this: CHOWN options user dot group, username dot group name. That means ownership. If you want to modify ownership, username we have to specify, then group name space file or dir. The same syntax we can use like this also. You can run like this or like this. You'll get the same result. Okay. Using CHOWN, we can change group ownership also. So without using CHGRP. So for that, run the syntax like dot group name, file name or directory. Only group ownership will be modified using using CHOWN. We can change ownership, we can change group ownership, we can change owner and group ownerships. Group ownership. If you want to change group ownership, we have to use CHGRP, right? You can use CHOWN also to change group ownership. So for that, we have to specify dot group name. Then group ownership will be modified. The group name. So this is how to change ownership, group ownership, and permissions on files and directories. It's a very important concept. Okay, so to provide security for data. So for to allow authorized users to access, unauthorized users to deny. Okay, so these are all traditional file permissions. Traditional file permissions. So we have advanced file permissions and access controls list and attributes also. Okay, so we'll see now access control list. ACL, access control list. Right, access control list. Okay, small example. So you have a users like user 1, user 2, user 3. So these users belongs to G1 group, or okay, dev group, development group. User 4, user 5, and user 6. These users belongs to test group, testing. And user 7 and user 8. These users belongs to admin group. Admin group. So we have a different groups and different users belongs to that group, right? See, along with that, the users are like manager, another user account. Okay, lead. There are 2 user accounts. These user accounts not belongs to any group. Okay, individual user accounts. So we have a project directory like Java app. Java app. So I have a project directory. See, this directory belongs to group G1, or we can use app, group name apps, username also app, username also app. So Java app directories belongs to app group and app user, right? Now I want to set permissions for dev group to read, write, execute on Java app. For test group, read and execute. Java app. Okay, read, write, execute on okay. So for manager, so have to give access like read and write, execute. For this user also read and execute. Okay. Example. Read, write, execute. These two users not belongs to any group. We have a three groups: dev, test, admin. But we have to give access for these three groups on Java app as per requirement. So this is our requirement. But Java app directory is related to app group and app user ownership. Okay. So using chmod, we can set different permissions on different groups and different users. Only we can set different permissions for one user, that is owner of the file. We can set different permissions for group, that is the file belongs to one group. Which group? That group. And others. Here we have three different groups. File is already having ownership and group ownership like this. We can set permissions for this user and group and others, but we can't set permissions for these groups to access this directory with the help of chmod. Only traditional file permissions we can set. If you want to set permissions are like different permissions for different groups and different permissions for different users on same resource, either file or a directory. For that, we have a access control list, ACLs. Here we have a command set FACL. Set FACL command. Using set FACL command, we can set or unset. We can set or unset access controls. Okay, so note down, to configure different set of configure different set of file permissions for different users, comma, different groups. On a single resource. And brackets, files or directories. Resource. So access ACLs are the solution, right? See, for that use set FACL. Set FACL space -m user ACL. Just note down the syntax. Okay. Set FACL space -m user ACL u colon. Here we have to specify a username. Then permissions we have to specify here. File or directory. Means what? To apply an ACL for an user. To apply an ACL for an user. So this is a syntax. So to apply an ACL for group, set FACL -m g group name permissions file or directory. To apply an ACL for a group. Right. Right. So next, note down, to view or see, to view existing ACLs, on a file or directory. Get FACL space file name or directory name. To view existing ACLs on a file or directory. Getf ACL file or directory name. So it shows existing ACLs. So next, note down to remove ACLs. Syntax: set FACL space -m. Which ACL you want to remove? If you want to remove user ACL, username. Then nothing to specify here. So no need to specify any permissions. Then file name or directory name we have to specify. To remove group ACL, set FACL ICM. Sorry, here you have to use X, not M. I'm sorry. To remove G, group name GRP. File or directory. Don't specify any permissions here. Or to remove user ACLs or group ACLs, just use -X. To remove all ACLs. So this is for to remove individual ACLs, user and groups. Okay. So if you want to remove all ACLs, set FACL -B. Set FACL -B file name or directory name. File or directory. So next, note down. Set default ACLs. Set default ACLs on directory. Okay. Set FACL is -capital R. Set FACL. Sorry. Set FACL -capital R -M. You can specify like this also. -R, -capital R, -M. Then user ACL or group ACL, anything. If you want to set user ACL, you can specify the permissions. Then dir name. Once you run this, the same ACLs will be applied on directory as well as inside files and subdirectories. Inside files and subdirectories recursively. dir name. Correct? So this is ACL. To set ACLs on others. Okay, others. So how to configure other ACLs? We'll see. Set FACL -M O. So need to specify any usernames. Others means all. Then permissions. File or directory. Other ACLs. Right. We'll see. Create a group user accounts. User add user1 and user4 and user7. Yeah, we have 3 groups, right? So from this group, only one user created for testing purpose. This user created and this user created. Just add users into this group. Okay, create group dev test admin add. Okay. Users also created. Now create a groups. Group add dev test. Okay, already exists. Fine. Admin dev test admin group. Five minutes. Okay. See, successfully added. Now add users into this group. Group mode, user mode. G PASSWD. We can use -a username. User 1. 2. Which group? Dev group, right? Dev. Adding user. Next, user 4 to test group. Okay. So then user 7 to admin group. Successfully added. Now make a directory /java app. Okay. So add user. User add app. Okay. Now change ownership and group ownership of Java app. We created directory, right, with login as root. So who is owner for Java app? Root. We have to modify, right? CHOWN app user account we created. We have an app group also along with user. One app group also created. Java app. Now try. Modified. Yes. As per scenario, Java app directory is related to app group. Owner is app. Okay. We have three different groups like dev, test, and admin. Some users belongs to these groups. Okay. Now we have to set different permissions for different groups to access. Right. Switch to user 1. Try to access Java app. Switch it. Okay. CD Java app. You can access. Nothing it contains. Try to create a file. What it says? Permissions denied. So because user 1 is belongs to other users, right? Not a owner of the file, not a group owner of, belongs to group, right? See, exit from this. Now set access control list. Instead of adding user into app group, then setting permissions on app group. So add ACLs on user belongs to one group, right? What is group name? Dev. Set FACL -m G group name dev. Permissions read, write, execute. Read, write, execute. Directory name Java app. Get FACL Java app. See, these are all existing permissions, normal traditional permissions. Now group is having full access. Dev group. Okay, added another ACL rule. Group ACL dev to given permissions like read, write, execute. Now switch to user 1. Try to access. Okay, cat. Yes, allowed. Hello ACL. Allowed, right? Yes. Now exit from here. We have another group. Test. Set ACL. Set FACL. What is that name? -m G group name test read and execute, not write permissions. Java app. So if you want to see that, get facl Java app. Added another ACL rule or not? Yes. Another group ACL test added. Okay. For test, permissions read and execute. For this, read and execute. The users belongs to test group. Now they can access Java app. Okay. Switch to user 4. User 4. See, directly we can access, right? ls/java. Directly user can read. Sorry. File name. You can read. Right? So try to modify, append. What it says? Permissions denied. Okay. Only allow test group users to read and execute, not write access. Exit and then set permissions on admin. Set facl -m G admin group read write execute. Then Java app. Get facl. Added another ACL rule? Yes. Okay. Now users belongs to admin group can also read and write execute. Read, write, execute. Okay. Okay, fine. We have a user accounts like mngr and lead. I'll give permissions for user accounts. Set facl user ACL -m username mngr read and execute, not write permissions. Read and execute Java app. Set ACLs for lead user read write execute. Now run get facl. Added user ACLs. So these permissions are traditional permissions. These permissions are ACLs. User ACL mngr read execute. User ACL lead read write execute. Now when you log in as lead, this user can read and write execute. When you log in as mngr, only user can read whatever the files under Java app. Right? Fine. su-lead. Yes. Hello. Created or not? Yes. Like we can set different ACLs on different files. Okay. So that is depends on requirement. We can set different permissions for different users, different permissions for different groups on same resource, either file or a directory. Okay. Using chmod, we can modify traditional file permissions. Using chown, we can change ownership and group ownership. We have a chgrp command to change group ownership. Using ACLs, we can set different permissions for different files and different directories. Right? To remove, set facl, right? Set facl -x. If you want to remove user ACL, that means so you want to remove access for this user lead. Just use real lead. Then no need specify permissions. Get facl Java app. So removed or not? Yes. Right? There is no write access for now. Lead group, lead user. Like we can individual ACLs, we can remove user ACLs or group ACLs. If you want to remove all ACLs, What is that option? -B. Whatever the ACLs on Java app, a file or a directory, all ACLs will be removed. Get FACL / Java app. So removed or not? Right? So this is access control list. Okay. So tomorrow we'll see advanced file permissions. We have SUID, SJID, sticky bit, and attributes. Okay.